So, welcome back for the next session. This one is all about batch size 1 production in real life. We have for this session 3 speakers. So first we have Ralf Kaunz, from Baumann Automation, our partner, and we have Birger Wegner and Joachim Schultis. They will tell you more about our own sensor factory, I4.0. Yeah, we have our own factory that produces sensors, and we have used many of the solutions we are showing today. But what is the reason why we implement it? What did we implement? Why? And what are the real benefits we can get out of this? And in this session, Mr. Kaunz will tell us more about the robot cells they built for us, and Birger and Joachim will give more information about benefits and how batch size 1 actually works. So, stage is yours.
Thank you, Jürgen. So, maybe let's start with the first question. What does batch size 1 mean? Let's take a look at this chart, which shows the development of industrial manufacturing in the last 200 years. We can see on the horizontal axis the product diversity, and on the vertical axis the produced volume per variant. And we can see that from the beginning of the industrialization, the main focus was on producing more parts of a single item, and this went, of course, on getting less and less diversity. This development reached a tilting point in the golden age of mass production in the post-World War II area. From that time, the trend changed. Customers started requiring more and more customer-specific products which actually meet exactly their needs. And this trend is actually magnified by the digitalization. So now even more and more digitalization comes to play, up to the extent of personalization, of mass customization. So you can imagine that companies who want to be active and successful in this field, they need a specific manufacturing system. A manufacturing system which is capable in producing single products at the cost level of a mass production, or a batch size 1 manufacturing system. Of course, also we as SICK are subject to this development. This is why, for the development of our latest product line, we decided to explore new paths also in manufacturing. So, Mr. Schultis, what were your main considerations when you started the planning for this new product line?
Yes, so Birger, first, thank you for the introduction and description of the historical development, which, let me say, perfect fits to that what we can observe from our market needs on the products we are doing. Exactly that what you described is this trend coming down to a higher product diversity, which at the end of the day leads to lower product volume per variances. And this is exactly that what we can face over the year, what we see, what is trended by the market. And exactly this was the main question we did as a first out of the shelf. How to build up a new operation system, and what is the prior leading? And the prior leading is how to fit the market need and what is the trend. And we can clearly say, yes, it reflects perfect our situation, and we do face market dynamics is increasing that much over time. It comes down for operations in volatile volumes as well, variances increases. And at the end of the day, it leads to two major things we put in place by design the system. The one thing is that we say, yes, by this trend, more customer individual products will come up. So the request for just-in-time delivery, for just-in-time production increases. And the second need is also mass customization, where we would say mass customization is the thing to face that we are able to deal with product variances under the condition of a mass production in terms of request for delivery times, product quality, and at the end of the day also the product cost. It leads to higher delivery flexibility, definitely. And the second pillar is increased resource efficiency was one of the major things we put in place, and one is that we said, okay, we go for a build-on-demand strategy. So we do not build for stock, we do not build for whatever reasons, we just build then if a customer order is in. And by doing this, you can reduce your inventory level on the one hand. On the other hand, it increases the needs to stay capable once a customer order is in to deal with it, which means also overall equipment efficiency is a real need. And For us, to summarize up, we have three major things in. Flexibility and adaptability is the key. This is the major key to serve this volatile demands, to serve the product diversity at itself. Secondly, we got rid of from this classical line structure, line with a U shape or what else. So we went over totally to a modular, to a cellular manufacturing system, which is a totally different approach and gives a higher degree of flexibility to serve with these variances. And third, at the end of the day, this is just a cultural thing, and we see clear this is the asset that we say collaboration is also a key. Collaboration between human and machines. So they interact together, they work together, and they find their way together how to achieve higher effectiveness and higher flexibility. And last but not least, for all, for sure, digitalization, as Berg introduced, is a key behind to make all of this happen at the end of the day.
Thank you. This sounds really interesting, but I would really like to learn more about it. Do you think it's possible to go there and take a look at the production?
Let's go.
Okay, let's go.
Already. What exactly do we see here?
So you just reached Freiburg-Hochdorf, where's the place our I4.0 NOW factory is located. It is in principle a manufacturing system consisting of a modular approach, modular cellular approach. We have automated modules, as we can see here in the background, added with hybrid as well manual workplaces. In total, the system itself gives a high degree of freedom to serve with product diversity. And as we have learned, product diversity is one of the major market trends. Product volume lower down and down, diversity is going up, and exactly that's what we need. High flexibility to deal with this to the future.
We are now standing in front of one of these mentioned assembly cells. Which technological approaches do you follow inside these cells to keep the flexibility high?
Yes, exactly. So when we talk about batch size 1, I guess it's crucial to imagine batch size 1 should be also go along with the economically sensible approach. And we get this by using free-scale processes. So we get rid of any kind of geometric defined processes. We switched over to free-scale processes, which are able to get another format, another design style only by software, by parameterization on the one hand. On the other hand, we get totally rid of any kind of manual setup work done by an engineer or by an operator or what else. Achieve this goal by using our vision systems, by using of intelligence in the software algorithm, by using robot guidance technology, let me say in total. This is the key to achieve batch size 1, getting in a higher scale of economy sense.
These are a lot of interesting details. How do you actually control the single cells, or how do you organize the collaboration of all these single cells?
That's a really important question, and let me say first, we always came out of the customer's perspective and the questionnaire, how can a customer define the type of product exactly? And that's what we did is, we're using in the entire ERP system a so-called variant management system, which describes the technical details of a product in a characteristics way. And the number of those characteristics we can choose, we fit it down to a so-called recipe. And this recipe is the input for the multi-agent system we are using on the shop floor to control on the entire value stream. And an agent itself is a small piece of software, have a functionality exactly for those processes needed, has a functionality on a module, on a manual workstation, and it, let me say like this, it is a digital twin of this module. And then we have some other agents responsible for the coordination of the shop floor, just to organize to run from the one process to another process or back or what else needed to go to the right product. And we have also the situation how to organize material transportation. And there's also an agent working on those questions, how to organize material transportation, the right material on the right place to the right time. All together, all agents together, we call it multi-agent system. And the sum of all is that what we say, this is the digital shadow or the digital twin of our factory.
This sounds like a very complex production system. How do you keep the overview, or how do you communicate with the single cells which manufacturing order is supposed to be produced?
Yes, exactly. So the answer is transparency. Transparency in the data, and therefore all of our material is transported with this tray located in this, and each of the trays is indicated with a RFID data storage. And on this RFID data storage we have stored in the manufacturing order number as well the location of the actual material. So that's why we can to each time say, okay, this material is now here on this place, it will happen this or that with this material, and we do see, okay, next destination in a 5 minutes time or what else is cell number 12, for example. So that's the kind how we can generate via track and trace system and via RFID technology a maximum transparency on the entire shop floor regards material on the one hand. On the other hand, we have the same system indicated on the product side. So we have on each product a data matrix code marked on the housing, and in this data matrix code a serial number is stored in. And on each cell we do read out a serial number. We connect it with the process parameters happen exactly with this serial number, and we can track the material down to each single component. And at the end of the day, we have the full transparency by data management technology on the entire material happening on the shop floor, as well on the product coming along with each individual devices going down to the component.
You just explained to us the organization of the manufacturing orders and the material flow. But how do you physically implement the material flow?
This is exactly when we talk about batch size 1 and efficient way to deal with batch size 1, one of the crucial questions to answer. And we have decided here not to connect on a hard end wire by a conveyor belt or what else from station to station. We clearly decided to go the flexible way, and we do not have a hard connected material transportation. So we are working with a fleet management system which is controlled by an agent, a decentralized organized software. And the fleet management system is controlling HSCs, so autonomous guided cart, which organize material transportation from one to the other. If it is raw material, or if it is work in progress material, or if there are finished goods to serve the distribution logistics, either or. And these HSCs are able to work in a collaborative way with humans. And exactly that is the degree of freedom we have to scale the flexibility that the fleet management HSC together with collaborative approach of humans can act in a high efficient, flexible way to achieve the goal batch size 1, dealing in an efficient and economical way.
Thank you very much for these interesting insights. But if we look around here, one can imagine that these cells are not sold via catalog.
You're totally right, and first let me say you're totally welcome for this question rising up, because this point out exactly one of the crucial questions we had for ourselves at the beginning of this project, because it was totally clear to us when we go to new ways, we need to have a partner, a strong partner on hand who is able and capable to go with us a new way and to bring us new innovative thinking into this. So, and it was totally clear we have to find a partner which is really open-minded, which is really capable to think about new things, to scrap away some ideas, to find new solutions. And today I can again say I'm totally happy and I'm proud that we found with Baumann Automation a really suitable partner for us, showing the capability, showing the openness, showing the creativity to think about new solutions, to go new way, and at the end of the day not only think about, just make it happen. Make it poorly happen, on-site the shop floor by make the machines, bring the system to life, give us the opportunity to run an Industry 4.0-like styled factory like we have today. That's why I can say again, thank you to Baumann Automation to work with us. It was a really pleasure. And what we have today is really unique, let me say.
Okay, so let's go to Waldkirch, because there we will meet Mr. Kaunz from Baumann Automation live in person, and we can talk with him about his experiences he made in our Industry 4.0 factory in Freiburg.
Let's go.
Okay. Oh, hello, Mr. Kaunz.
Hello.
Well, we just went to Freiburg to see the manufacturing, the production site there, and it was very impressive to see the robot cells from Baumann Automation. But I was wondering, what did it mean for a machine builder? What were your experiences with this project?
So I'd like to tell you about our experiences in a few slides. So let's start.
Yes, please.
Thank you. So thank you, Mr. Wegner and Mr. Schultes. Welcome from my side. So my name is Rolf Kaunz. I'm a sales engineer and your contact person for everything to do with automation solutions at Baumann. Today I'd like to give you the perspective of an integrator to production of batch size 1. First off, a few more words about Baumann Automation. It's a family business in the automation industry from Hamburg, Germany. With 700 employees and global holdings, we are a manufacturer of turnkey assembly and test production lines. Based on our standardized automation platforms paired with our own software development, we are offering different solutions. First, I'd like to look how conventional line automation is done right now. We've tied together production lines based on certain process steps. Baumann uses its own automation platform called Robox, and we can see a picture of a line like this. Such systems are characterized by fixed processes, high through outputs, and low flexibility. All this does not have to be a disadvantage if you have to produce large quantities and small variants. For our customers, this means that systems are only set up sporadically, manual processes are accepted. This means that grippers are changed, material that is fed in as bulk material, for example, must be emptied, or only just to name a few of them. During conception, the various process steps are designed accordingly under the requirement of a high machine throughput. This means that there is usually only a little room for freedom in the design. From the software point of view, only relatively low demands are made. Often data is only processed in one direction. Machines' status are reported and process parameters are saved. That's it. And for machine operators, there's only little effort required for production control. The advantage are a very high output with really low unit production costs. But disadvantages, however, this is the expense of flexibility. So what are the reasons why a conventional system might not be suitable to you? Configurable products within a product family, for example, these sensors here, where the SIG experts can certainly explain much better than I how precisely you can receive your sensor, so-called low volume, high mix productions are one reason. They are the same, but not in every detail. For production control, there are enormous numbers of possibilities. Mathematically, there are 300,000 possible configurations, just example named different connection threads. Possibly this means different stations or their elimination. The scaling output by adding or removing stations can be easily adjusted. Fluctuation in number of pieces, even only in the variance, can be absorbed more easily. The features, we have set up the system for SIG as a standalone manufacturing island, cell or modular system. Others like to call this a matrix. So what are the advantages of such production environments? The design allows a really high warranty at low unit production costs. It is very easy to adapt to changes, both to changes in product and to the mix of different variants. It therefore offers a high degree of flexibility. So for SIG machines, the link with automated guided vehicle was chosen. In this way, pure production merges with logistics. We have already heard about the module again from Mr. Schultes. This controls the production. Depending on the product to be manufactured, different production sequences are now possible. The possibilities that results from this is an optimization in case of malfunction, variable and repetitive production steps. For example, screw driving processes can possibly carried out with one cell, or balancing if you have got more than one production step and you can control it alternatively. Receipt and in advance planning are very important. And depending on the product, different paths can be run through. And now let's talk about the tasks of an integrator. We can also design solutions for this application based on the Baumann robots. It is very flexible. And this much upfront, such concepts can only be successful implemented together. Client and contractor work much closer together. This is also how mutual understanding of problems are developed. In order to enable the process, as described above, some aspects have to be implemented to the machines. Manual changeovers are no longer practical in this case. This means that systems should be set up automatically. Robots, therefore, are equipped with gripper changing systems. This is not revolutionary, but it usually increases the effort compared to a conventional automation. And for the later commissioning, this already results in higher programming efforts. And likewise, material must also be prepared automatically for practical process steps. Even the smallest part must be taken into account here. And therefore, we designed the Baumann Rackbox handler for this purpose. A high level of software system are less passive from now because it's going to set up the machine. So the Baumann Rackbox handler is a storage unit to store some parts directly to the machine, and it is loaded by an AGC. So we have already heard from Mr. Schultes about the standardized boxes. Those are fitted into the system. Yeah, so batch size 1 is on its own is not the new magic bullet. Conventional systems will also retain their right to exist. Contact us at Baumann at an early stage, and we will be happy to design a suitable solution for you.
Thank you.
Thanks a lot for this great presentation. It was really interesting to see, and the good thing is you always have to practice what you preach, and this is especially for the many countries where you have as a customer contact with. We always talk about these solutions, but it's good to see that it's all fitting together, and especially the fact that we have the experience ourselves is really a big benefit and makes us more confident in our discussions daily. There is not too much time, so I'll pick out one question. Joachim, it's one to you if you're okay. Is the agent system similar to an MES system?
Okay, I understand this question because exactly this is one of the leading questions we had, let me say, five years ago as we talked about this and think about. I would say it depends on the flexibility of the MES system. So in principle, when we step back 5 years ago, as we talked about, we found typically MES system as a classical introduction in the automation pyramid as a layer-to-layer communication. And it was totally clear for us that a system where layer-to-layer communication is established will not work for a modular approach where we can where we need a higher degree of flexibility. So we said we need something different. It must be modular, it must be more flexible. And that's why the approach of a multi-agent system was from that time the more suitable to us. And the problem we had, we haven't found on the open market something like this. That's why we decided poorly we have to do by our own. And that's why we now have a multi-agent system implemented, decentralized software together, connected, made by our own, for our own purposes.
Okay, thank you. Well, unfortunately, time is up. I have the feeling that we can continue for many, many hours. So I invite you to get in touch with your local contact. And at least one thing, you see the sensors are well being produced and just in time, so don't stop buying them. You'll have them at the blink of an eye. So thanks a lot for the presentation. And I see you in a few minutes for a session about energy saving. Thank you.